Welcome back to the NASA Citizen Science Community Workshop Series. I'm your host, Sarah Kirn from the Gulf of Maine Research Institute. Once again, we'll start with reminders. Please use the chat to introduce yourselves if you've not done so already. And if you find that chat distracting, shut it down or move it aside. Note that the chat default is to send your chats to panelists only. When you write a chat note, use the blue box just above where you type to redirect your comments where you want them to go. Please use the Q&A tool, which you'll find in the footer next to the chat tool, to submit questions for our speakers. You can now vote for questions in the Q&A tool and comment on them. If a question seems to have vanished, look at the top of the Q&A window for the tabs to access answered questions. It's probably there. Today, we'll have 3 pauses for live questions, 2 short ones and 1 longer one at the end. If we don't get you to your question in one of the earlier pauses, we may just get to it at the end. So welcome to the 10th event in our series. While you've seen a lot of me, I am merely the figurehead of the team putting on this show, the tip of the iceberg. If you want to see who else is involved, go down to the footer on the website and follow the link to the planning team, and you can see our pictures and read our bios. I want to personally thank each member of the planning team for all they have done, from designing the program with me, to convening the panels, to engaging you all in the chat, and so much more. Thank you. I also want to call out the Citizen Science Association, the Gulf of Maine Research Institute's partner in putting on this series. If you've enjoyed the broader conversation we've had about the practice of citizen science, I encourage you to take a look at the Citizen Science Association and the many opportunities for professional development that they offer. The CSA is a member-driven organization that connects people from a wide range of experience around a shared purpose of advancing knowledge through research and monitoring done by, for, and with members of the public. They put on a biennial conference, publish the peer-reviewed journal Citizen Science Theory and Practice, and offer online networking opportunities and webinars. Their member-run working groups address hot topics in the field, from data and metadata, to education, to integrity, diversity, and equity, and more. Check them out and consider joining. And now, as has become our practice, we'll open our event with a conversation with Dr. Marc Kuchner, NASA's Citizen Science Officer. Thank you for joining me again. Marc, it's fun to have these conversations, opportunities to reflect with you about the series at the beginning of our events. So I wanted to start by just asking you what lingering questions or thoughts you might have about the panel and evaluation. What are participants learning, and how do we know?
Thanks, Sarah. I've been learning so much. You know, one thought that really struck me during the evaluation panel and still got me thinking was this notion of the importance of reflection. How citizen scientists learn much better when they stop to reflect on what they've done. You know, how do we create opportunities for reflection? How do we encourage our citizen scientists to reflect on the science they've learned and on the concepts that they've learned? What a great challenge.
Absolutely. And how do you do that at the scale of a really successful citizen science project where you have thousands or tens of thousands or hundreds of thousands of people participating? It becomes kind of a daunting and exciting challenge to think about.
Yeah, the groups of the most passionate citizen scientists who are working closely with science teams, they are having all kinds of wonderful conversations. But how do you scale it to a larger group? How do you get 100 people to reflect? How do you get 1,000 people to reflect, or 1,000,000 people to reflect? I mean, that's probably a very deep question, I think, that's probably challenged orators over the century. But it's one that it doesn't sound impossible.
Yeah, there were some moments of hope, and it might be not a huge reflection, but just a little prompt that gets somebody to think about a skill, or maybe it's a question connected to the training module of a project, or something in a discussion forum.
Yeah, maybe it's a conversation that citizen scientists have with one another.
Yeah, which is really exciting. And to what degree do we have to worry about misconceptions being promulgated if we are encouraging that? Or how can you check, or how do you design those interactions and small group discussions to support good learning if we need to?
We did an experiment in the Disk Detective project where we took our super users and we paired them up at random. And it was tremendously productive. They taught each other things, and they crafted their own tutorials and their own sets of notes. And it resulted in this just flurry of excitement and productivity. And I know that there were situations where people were struggling. I certainly saw instances where the matchups didn't work well, but it was generally the situations that I saw, they were cases where there was never a bad actor. It was just that people were both passionate about doing it, and they had slightly different concepts of what was most important and what was the right answer. And they would disagree, as any professional scientists do.
Certainly.
Right, about the right way to proceed.
It's curious to wonder what works for those super users who are spending a lot of time and really getting deeply involved in projects. What works for them? Would that work for the kind of the group of people in the middle who are not quite as active?
Right. Can we pair up the super users in a project with the next tier of users? I don't know what to call them. There's
like in education,
in training, super.
Yeah, in education, you talk about near peers. So finding someone who's a little bit better than you are at something, or a little older than you, and that can often be really captivating or motivating. So maybe that idea could come into place. And maybe somebody out there will have a seed funding idea for a citizen science project and explore that.
Well, that brings up a challenge that we have at NASA, which is that citizen science spans multiple divisions, right, at NASA, and a lot of the funding that we've had is to accomplish science, and you wouldn't even apply for that funding to do a project unless you could clearly connect the dots between what you're going to do and what science is going to achieve. Right. But then there are also programs like science activation that can support other kinds of engagement activities along these lines.
Yeah. So maybe to bring it back to our panel for one last question with you. So I was really struck that the evaluation panel spent so much talking about project design and talking about how if you don't design for certain learning to happen, it's unlikely to happen just because you built something. And one of the things that I've noticed through this series is I've learned more about NASA citizen science projects. It's so many of the wonderful, great discoveries in NASA citizen science projects have come when a citizen scientist started poking around and going beyond the structured task of a project, maybe going beyond what they were expected to do or doing something they weren't even invited to do, and recognizing something unusual. And that's where the great discoveries have happened. So you've designed several citizen science projects. How do you design for that kind of unexpected serendipitous discovery? Do you have any comments or thoughts on that?
Oh, it's so true. The serendipitous discoveries from NASA projects, I think they're really some of the top discoveries are the unexpected ones. There's the Dipper star phenomenon from Planet Hunters. Nobody knew that those existed. These stars that kind of wink out for days at a time. The oldest planet-forming disk from Disk Detective, and the oldest white dwarf with a disk, that was discovered by Melina Thieveno, who realized that a project that was intended to find brown dwarfs could also find white dwarfs. and she found a record-breaking one. The whole Sungrazer project was serendipitous. The notion of all of these sun-grazing comets, I mean, scientists didn't even ask for it. They just started getting bombarded with emails from members of the public who were seeing interesting things in the SOHO and then the stereo data, and felt the need to put up this website to deal with it. So, I mean, you asked, how do you design for these things? I think the way to design for them is to have more communication channels, and to be able to redesign once you see a new direction that your project could be headed in. I've seen project leaders make the mistake of thinking that the problem that they ask the public to do is going to be the problem that reaps the most science. I would say that project leaders should assume the opposite. That you should assume that the task you ask people to do is just the teaser. That's just the beginning of the relationship that you're building with your citizen scientists. And you get them interested in working with you through that clearly defined task. And then you build good relationships, you build good channels, so that when 100 smart people from around the world start sending you other cool ideas, including a few that are better than your original idea, you're ready.
Interesting. That's a profound statement, Marc. So set out the project, but then make sure that there is a clear, obvious channel through which people can send other ideas to you.
Yeah. I mean, I've seen projects use, there are lots of mass collaboration tools, right?
Right.
Beyond citizen science projects. Just think of the way you work with your colleagues on other science teams. There's Google Docs and Google Sheets and Google Forms and yeah, that's a lot by Google. But the point is, we have all these other tools that you can use to collaborate with a team, and any one of those could be a tool for a citizen science project or a sub project within a citizen science project. So I see projects taking advantage of those tools and just running 17 different side projects simultaneously with different subgroups of their citizen scientists and breaking new ground.
Yeah, interesting. And reflecting with one another.
Reflecting with one another through the magic of Google Forms.
Absolutely, or any online collaboration tool. Well, thank you so much again, Marc, for joining me for this moment to reflect on our series before our events. Talk with you next time. Thanks. Today's event is dedicated to just one platform, the Zooniverse, which by its own description is the world's largest and most popular platform for people-powered research. While there are many important platforms for citizen science, any of which might be worthy of a showcase event, the Zooniverse has a few distinctions that make it the most common platform for NASA citizen science projects. The Zooniverse platform is designed to address the major challenge of 21st century research, namely, that we have technology that lets us collect unprecedented amounts of information. But then what? How do we turn that information into new understanding? The Zooniverse platform allows scientists to put that information, images, videos, artifacts, in front of volunteers who answer simple questions to classify or interpret the information, dramatically accelerating pattern recognition and discovery. Since its early days, the Zooniverse has intentionally merged the power of technology with the special powers of the human brain. We'll hear more about that today. We'll also hear more about the new collaboration between NASA citizen science and the Zooniverse and how you can stay informed. We have two stars from the Zooniverse with us today. The first is Dr. Laura Trouille, who many of you will recognize from our July panel on broadening participation in citizen science. Dr. Trouille holds a PhD in astronomy. She both leads citizen science efforts at Chicago's Adler Planetarium and serves as the co-lead of the Zooniverse with Dr. Chris Lintott, Previously, she has worked as an observational astronomer looking at supermassive black holes and as a science education researcher looking into the impact of lesson plans that incorporate computational thinking into K-12 STEM education. And as those of you who follow Laura on Twitter already know, she's also a former roller derbier, which is a more visceral application of her undergraduate degree in physics. Our second Zooniverse star is Dr. Cliff Johnson, who also holds a PhD in astronomy and is the Zooniverse postdoctoral fellow at Northwestern University and the Adler Planetarium, serving as the Zooniverse science lead and NASA liaison. His research focuses on improving our understanding of star formation, and he conducts this research, at least in part, through collaboration with the Zooniverse community of researchers and volunteers. Cliff was part of the team of scientists behind the immensely popular and consequently very short-lived Andromeda project on Zooniverse, which invited volunteers to search Hubble Space Telescope images for star clusters. Today's program will be broken into 3 parts. First, we'll hear from Laura on the Zooniverse platform and the Project Builder tools. This will be followed by a brief live question and answer period with Laura to address any burning questions. Next, we'll hear from Cliff about machine learning in and through the Zooniverse platform. This too will be followed by a brief live question and answer period to pose questions to Cliff about machine learning. And finally, Laura and Cliff will share more about the Zooniverse NASA partnership. And we'll come back live with Marc to answer questions about that and have a broader discussion. So, Laura, kick us off.
Thanks so much for having us. In this first section, as you said, I'll provide an overview of Zooniverse, the tools available, lessons learned, and guiding principles from the citizen science community that we've applied. Millions of people worldwide enable research through Zooniverse that would not be possible or practical otherwise. Since 2007, Zooniverse has partnered with hundreds of researchers, leading over 300 projects to date. From astronomy to zoology, cancer research to climate science, arts and humanities, our platform provides researchers a set of shared tools and a standardized online infrastructure. Each week, about 200,000 people participate, contributing millions of classifications and tens of thousands of posts in the forums. It's equivalent to about 40 years of full-time effort each week, discovering planets around distant stars, transcribing historical documents, tagging animals and images, and marking cell structures for cancer research, and much more. So the image on the right shows the Zooniverse projects page with over 80 active projects, each led by a different research team. The figure on the left shows the explosion in the number of Zooniverse projects since our launch of the Project Builder in 2015. It takes tremendous resources, both budget-wise and people effort, to build online citizen science projects from scratch. Prior to 2015, our team was only able to build about 3 projects each year. We then took all those lessons learned and built a shared infrastructure so that anyone could build their own crowdsourced research project for free using simple browser-based tools. We wanted to democratize access to these research tools so web development expertise and funding were no longer the barrier. So we went from launching about 3 projects per year to supporting research teams in launching about 1 new project per week. I'm going to highlight a few examples for those who aren't familiar with Zooniverse, just to give a sense for the different project types. So I've pulled examples from projects led by research teams supported by NASA, since this is the NASA Summer Citizen Science Series. So here's Floating Forest. It's showing the standard setup of an image or video file or audio clip on the left, and a task and the task instructions on the right. The video here shows a participant marking giant kelp forests on the NASA satellite data. This is a project looking at 30 years of data and looking at climate change impact. So in every project, multiple people classify each image. In this case, 15 people, and we aggregate the responses to create the consensus result and confidence in that result. A guiding principle relevant across all citizen science programs to highlight from the start of this talk is building into our infrastructure and foundational processes data quality assurance practices. So in our case, it's through multiple classifiers, our aggregation processes, and comparison with expert classifications. There's actually a great article that just came out in the Citizen Science Journal of Theory and Practice called Still in Need of Norms, The State of Data in Citizen Science by Bauer, Cooper, and others that provides a really useful framework and guidelines around data practices. For us, data quality is deeply intertwined with our driving mantra, which is don't waste the participants' time. Make sure the data they are providing are of the quality you need for the research you want to do. This slide shows Snapshot Wisconsin, which showcases our survey task type project, where participants use the filter tools to narrow down from about 60 choices to fewer to simplify the task. And all the help guides and information are directly embedded in the task itself. So all that help text and information is embedded in the task itself to really lower the barrier to entry as much as possible. So you truly don't need any prior expertise to be able to participate. This next project, as an example, is Disk Detective. So this is a project where you're searching for debris disks around distant stars. These are nurseries for baby planets. It utilizes the multiple choice type task and the flipbook feature. In addition to the thousands of people who have participated in the classification task, there's a robust community of super users who participate in advanced tasks and are co-authors on several of the many publications that have come from this project. And a final example for now is Planet Hunters, or Planet Hunters tests, where you're looking for dips in light curves as an exoplanet passes in front of a star. So not only can images or video clips or audio files be the subject of a project, but also interactive data plots like this one. So all of those projects and many, many more have been built using our Project Builder platform. Anyone can use the Project Builder to build their own crowdsourced research project for free. Now that the Project Builder exists, for online data processing projects of this type, all our resources and time can now go directly into research and community engagement rather than in the web development effort. So here is a really brief, less than 2-minute video that just shows how simple it is to create a Zooniverse project using the Project Builder tools. So it's a simple, user-friendly, browser-based interface. Here I am creating a test project, but you can see that it's just about inputting text into open fields, dragging and dropping images. And one of the powers of the Project Builder is you can immediately see what the project looks like in the web, so how the public would see it. And that lets you see, as you're building it, what the final product will be. So here, I'm just dragging and dropping a couple images as the subject set. And this test project happened to be in using galaxies. My background is in astronomy. So you drag and drop your images, and then you click on the workflow section to create whatever task or whatever you want your public participants to do. So here I'm choosing a multiple choice type question task, and it's going to be a simple yes/no question. As I'll scroll down, I'll be able to click a button and immediately see what the classification interface looks like. And so within less than 2 minutes, I've created a demo project, and it's really just to really hammer home how simple it is to use these tools and build a project of this type. So a wonderful outcome of this talk for us is if all of you go and play around within zooniverse.org/lab and then share this tool with your colleagues and just let them know that it's free for anybody to use, and it's just meant to help people unlock their data and engage the public in something really interesting and potential for discovery. So in addition to the Project Builder interface, we've built translations.zooniverse.org, which enables teams to crowdsource the translation of their project into any language. So for example, here's the Polish version of Backyard Worlds, which is another NASA-Zooniverse project. I also just wanted to mention that projects built using the Project Builder platform for certain task types also automatically appear within our Zooniverse mobile app. The app has proven an incredibly effective way to do quick yes/no type workflows. For example, are there sea lions in this image or not? So once a project is built, we then send it out to our community for review tens of thousands of our participants have signed up to be reviewers of new projects before they launch. Or a guiding principle that's relevant to all citizen science efforts is how important it is for the participants to have an opportunity to give direct feedback on project design and implementation. The public's feedback on whether something is confusing, if the research case is unclear, if the task is too complicated, or many other areas, is essential in creating quality projects that are engaging to the public and generate good data. And if a project makes it through review, then it's time for launch. And I'll note that a number of research teams purposefully never launch publicly. So either they're using Zooniverse just as a standardized classification tool within their own research team, or they have proprietary data that can't be shown to the public, or some other reason. Just to say that the project builder supports private projects just the same as public projects. For public projects, the research team commits to being engaged and in direct communication with their participants throughout the rest of the project's life cycle, from classification to data analysis to publications. And that communication happens mainly through each project's dedicated discussion forum, which we've referred to as talk. It's a typical forum setup, except that you can have object-oriented threads, meaning threads based around the image you've classified. So here's the talk from Backyard Worlds, where thousands of people have posted. A critical role within our talk forums are our moderators. These are public participants who become deeply engaged in the project and are essential in helping to create the supportive community culture, and where all feel comfortable sharing ideas, being wrong, learning together, and moving the discussion forward. Through these forums, the public engages with the researchers around the science, their interests, and the weird and wonderful things they see while participating in the project. And talk is actually where many of the most interesting discoveries have been made. Because you have so many eyes on the data in a crowdsourced research project, you're bound for someone to notice the unusual or the rare. So from Zorilla sightings to the discovery of a new class of galaxies called the green peas, talk has proven an essential mechanism through which the public can flag the unusual and initiate discussions with each other and the researchers into totally unexpected and new areas of research and discovery. So to finish out this first section, I wanted to dig a bit more into a few of the guiding principles and best practices we've followed. Many have been echoed throughout this summer citizen science series, and I encourage in the Q&A for those in the chat to share their examples and additional guiding principles that are at the core of your efforts and your impact. So for starters, as with any research effort, the best citizen science projects give themselves time and space to start small, experiment, and iteratively improve with direct feedback from your participants. Another is that Zooniverse has deeply benefited from being a partnership from the very start between a museum with deep expertise in education and outreach, so the Adler Planetarium in Chicago, and our partners at universities, the University of Oxford and the University of Minnesota. This has meant that as part of our foundation, we've recognized and valued the expertise and culture each brings to the table and how that makes for a richer experience. And this has translated into deeply valuing both the public engagement goals and the research goals, and putting structures in place that support and enrich both of those goals. This principle of placing partnerships at the center of new citizen science initiatives was one of the themes of the broadening participation panel earlier in the summer series, which I highly recommend revisiting if you missed that session. Related to this is the fourth bullet that starts with creating as low a barrier to entry as possible. A recurring theme this summer has been around the desire to provide a true depth of engagement for our public participants. And I fully agree with the need for that. But I wanted to add to that discussion that there is important value within our rich ecosystem of many different citizen science projects and platforms for lighter touch moments. So 10-minute swiping right or left during your commute on whether sea lions are present or not. It is healthy within our ecosystem to have these low barrier to entry Spark experiences. And it's critical that these Spark experiences make all feel welcomed and invited to go further. And then it's critical that we provide clear pathways and clear support, particularly for those underrepresented in STEM, from those Spark experiences to opportunities for deeper engagement. So we do this through our Zooniverse Talk discussion forums, through advanced tasks that lead to co-authoring articles and more. The discussion of this summer series has also reinforced our commitment within Zooniverse to creating pathways from our projects, from Zooniverse projects, to other citizen science opportunities. And it's just been so lovely to hear about all the different projects and programs and ways people are engaging the public in science. And in particular for citizen science programs that are addressing underrepresentation in STEM and or are led by minority serving institutions and organizations. And so that's been a real lesson for us from this summer in our society, but also this summer series, just to recommit to that and those types of partnerships. Embedded in all these ideas is a profound respect for our public collaborators, a design driven to not waste their time and value their knowledge and expertise.
So it's my pleasure to kind of introduce and talk about Zooniverse and the directions we're heading with machine learning. Because Zooniverse, as being a kind of people-powered research platform, humans are definitely going to continue to be a core piece of what we do, but also this is kind of looking ahead to future directions and where the future of machine learning kind of fits into that story. And so to start out with an example of my own from kind of astronomy, close to my heart, the fact is that with the growing kind of volumes of data in astronomy, but also across many different domains, that we are going to need help from machines. And so to take an example here of galaxy classification in the vein of Galaxy Zoo, kind of one of the first Zooniverse project that was ever launched. Right now, the Galaxy Zoo project can collect a few thousand galaxy classifications per day. But with just the enormous explosion of new observatories, 3 kind of shown here, all featuring very large format, very large data kind of volumes that will be coming in the forthcoming years, later in this decade. There's just no way that human classification on its own will be able to kind of keep up with this steady stream of data. And by the late 2020s, we really will need to take a different approach. And so this is exactly where machine learning and the power of machine learning comes in, because we can actually kind of leverage, hopefully, the advantages of both human classification and machine classification together in order to kind of move forward and produce great science. I did want to touch on a few topics or just a few points here that, although I think mainstream media may try to tell you that kind of AI and machine learning will solve everything, that there certainly are still challenges that kind of motivate us to keep humans in the loop. And so some of those challenges include the fact that any kind of machine learning algorithm will require training data in order to get kind of brought up to speed. And this is a growing kind of use case for Zooniverse projects and other human classification projects, is to create data sets of these initial labels. But it's also important to remember that not all tasks, classification tasks, fall in this kind of big data category. There are plenty of kind of small bespoke Zooniverse projects where a suitable training set size is actually the size of the data set itself. And for some of these smaller projects, bringing to bear a very complicated machine learning algorithm is somewhat overkill. And a third thing is that there still are, and this was actually a point brought up a few weeks ago in the machine learning panel talk, that there still are tough problems that even kind of the top machine learning algorithms can't quite handle yet. And so one kind of known to us in the Zooniverse is the fact that handwritten text, especially in kind of old historical documents, is still a somewhat unsolved problem. And there are still plenty of kind of tasks where, either off-the-shelf machine learning algorithms or even models that have been trained with data over time still don't provide quite the kind of the silver bullet solution that research teams are looking for, and that humans can still do better. And these human classifications really are still a very valuable resource. And also not to forget that, oftentimes just the curation of these large data sets provides, a huge amount of effort required, and just, the problems continue. And finally, and this is really important because I think we see this a lot at the Zooniverse, is that there are, 4 out of 5 project owners would say that they're interested in machine learning. However, that still leaves sometimes a deficit in terms of the number of teams who really have these computational skills and expertise to really kind of bring machine learning fully to bear on the problem. And so for now, we'd like to kind of find a hybrid path forward in order to do the best we can with some of these research data sets. So what is the future of people-powered classification? Where does Zooniverse fit into this? So at the Zooniverse, we like to think about kind of a few different aspects of how kind of the continued human classification, keeping people in the loop, can basically be used moving forward. And so a few of these is to, number one, simply make the best use of human classifications when they're contributed, and try to improve the efficiency of how we make use of those classifications on certain projects. Second piece is to actually start incorporating machine learning classification into human workflows. And I'll talk about the details of all this later, but really trying to bring, some of that kind of computational skill and power into these problems. And finally, I think this is really kind of the hybrid kind of conclusion that we're aiming for, is to really truly combine machine and human classifications in kind of the best way possible. And let's try to get the best of both worlds. But a few other kind of points to remember kind of as I go through these kind of different solutions that Zooniverse has sought, is that some tasks just are still very hard for computational kind of frameworks. Second, that humans are complex. We have to remember that if we are doing people-powered classification, that we really need to respect and honor the fact that these participants are not just an algorithm, a different algorithm, but they really are people that we really need to take care of. And so the third point here, that volunteer participants really are the core of citizen science and deserve that respect. And whether that be not wasting their time or basically just honoring kind of their participation and their enthusiasm for the work. And so keeping that in mind as we move forward. So for humans and machines, I'll just kind of start out with starting simple. And so we should really just try to first make the best use of human effort however we can. And so for the Zooniverse, that has led to an explosion of kind of a cascade filtering workflow setup. So here the idea is that instead of having kind of one task that is presented to a participant, that we actually kind of try to break up complex tasks into simpler tasks. And that is an advantage for a couple of reasons. So here I take kind of a typical cascading filtering workflow for one of our ecology projects, for instance, snapshot sharing together. And so if we actually start out with a very simple question, is the image empty or not? Is there any species to classify in this image? That can actually be broken down into a nice binary question. And for those images that are actually empty, those can be filtered out immediately. So without having to actually go through kind of a very complex survey task and obtaining the species classification, we can actually start to filter out a lot of the data very early on. And I'll also say that using the mobile app, as Laura introduced earlier in the talk, that can actually lead to very speedy classification and filtering of an initial data set. Not only are we able to kind of retire some subjects from a workflow very early on, but also we'd like to use kind of some of our computation ability to impose kind of computational retirement rules. And so the default in the Zooniverse is basically just show every subject a certain number of times, whether that be 5, 10, or 15 classifications. So this is very important for building up consensus. However, some kind of easier subjects can be, it becomes very clear what the consensus is, after only a fraction of the total number of classifications. And so here we'd like to be able to use, kind of computational rules that are imposed by kind of our machine backend in order to actually provide some early retirement. And so whether that be, if the consensus reaches 80%, then we'll go ahead and retire that subject. And so these are all kind of ways of not only making the tasks more efficient and getting through more data more quickly, which is great for research teams and for volunteers, but to also really kind of focus the effort that our participants are providing, kind of where it makes the most sense and where it can make the most impact. So a second kind of pathway for kind of including machines into workflows is to actually start using outputs from kind of machine classification programs. And so here I'm going to talk about two examples that are currently live on the platform. So the Catalina Outer Solar System Survey, which is a brand new NASA-funded project, a NASA citizen science project, and also Supernova Hunters, which the project has been around for a while. And so starting out with Catalina Outer Solar System Survey, the idea here, and kind of in general, is to actually take the outputs from some machine classification that may be able to really narrow down a very, very, very large search volume, a lot of data, and really narrow it down to the maybe 5 or 10% kind of smaller, more tangible list of candidates here for trans-Neptunian objects out in the outer solar system, and allow human classifiers to actually kind of narrow in on that small subset of data. And so here, volunteers are able to kind of view images and be able to classify objects as being real, as objects that are kind of transiting through different parts of the image, or bogus, whether that might be an artifact or other kind of blip in the image. And so similarly, Supernova Hunters also uses basically an algorithmic output here from a convolutional neural net, which runs on the data, identifies the best candidates, and then presents these candidates in a much reduced number to human volunteers to actually kind of do the last vetting. And so I think both of these projects are great examples of where humans are kind of taking on a validation rule in order to say something about using all that computational expertise, but also still keeping humans in the loop so that they're able to basically provide that very useful and kind of very useful input about the data. So this has actually been a very fruitful kind of way of moving forward. And so here on the slide I'm showing here on the left-hand side, it's actually comparing kind of scores of how a machine would kind of rank either as a real object in red or a false object in green, different candidate objects. And here the idea is that we really want all of our red points to be in the upper right-hand corner. And this example from Supernova Hunters really actually highlights that it is really through the combination of the machine score on the x-axis and the human score on the y-axis that we actually are able to create a much better kind of combined hybrid result. And so here you can see that if you kind of drew some threshold at like 0.8 machine score, that you would still have lots and lots of these green points on the right-hand side. However, if you include the human score and kind of pick, just the upper right-hand corner of this plot, that can actually get you a much, much better result. And here is kind of a classic example where the machine classification is often giving something that is very noisy, that has a lot of false positives. And the human classifications on top of that are able to actually really differentiate between some of these different candidates that the machine really can't sort one from the other. But at the same time, the machine is also providing much better completeness and can really kind of search a large volume of data in a very rapid amount of time. And so here, it's really that machines and humans together really being very complementary show one mode that I think is very fruitful for the future of kind of trying to combine the best of both worlds. And so finally, I wanted to give an example of where, really we're taking this kind of combining human and machine classification and really taking this to the next level. And so this example comes from work of researcher Mike Walmsley at Oxford, and is currently live on the Galaxy Zoo project, where we're actually, the team is using an active learning technique. So instead of just kind of trying to narrow down to a subset of images that may be still unknown to the machine, or otherwise needs kind of some like additional vetting, active learning actually says, okay, let's train an algorithm, and then the machine will actually ask humans to basically provide their input on cases that it's not sure about and where it actually can gain the most kind of leverage and improvement by actually getting classifications from a particular set of subjects. And so this is actually, a very exciting new way of doing kind of machine and human collaboration, and has been live for quite a while. And so this is actually, helpful to, basically for the human side, that you don't see very common kind of these like smooth elliptical galaxies that you see in the center of the slide. And really you're, focusing the human effort where the machine tells you it needs the most help. And so again, this takes a little bit more kind of technical infrastructure in order for, the machine learning algorithm running on an external machine to be able to talk to kind of the Zooniverse platform and system in order to really be able to make these subject selections in real time. But this is all work that is currently ongoing on the Zooniverse and has started to work successfully in this kind of first experimental mode. And so just to kind of close this out, talking about, I think there's very exciting kind of avenues for combining human and machine classification. But one big piece of that is, building some of this enabling infrastructure that will allow us to kind of use these different modes of working together. And so for the Zooniverse platform currently, and so Caesar is actually a very nice computational backend tool that allows us to do many different things, whether it's calculate these early consensus or to send kind of subjects and messages from one workflow to another, or even to communicate with external machines, like in the case of the active learning. And the Ptomptis API is another way of actually having technical infrastructure for computational systems, both in the platform and external to the platform, to talk to each other. I mean, I think one kind of big picture idea is that, at the Zooniverse, we've really tried to kind of take those first steps. And that includes, basically starting small and trying to, do the tasks that increase efficiency, and allow us to start using some very straightforward algorithmic tools. But at the same time, starting to experiment with some of these kind of more complex and more sophisticated machine learning methods. And through these experiments, we're able to really start to prototype what these communication pathways need to look like, and how to basically scale this up. But to just close out, on this kind of machine learning discussion in the Zooniverse, I do want to emphasize that human engagement critical to science outcomes, and how that we really need to be respectful of our volunteers, of the participants. And so as an example of where that can get a little complex, I'll use an example that actually deals with this kind of empty or not question from an ecology project. And so this was a great paper that was written up where there was basically two conditions set for volunteers. One, where a machine learning algorithm was actually used to, identify empty images and to basically weed those out. And then another kind of workflow in a more traditional mode where, participants are seeing all sorts of images, empty and not. And what we noticed was that if you actually remove those empty images from a workflow, that the participants who ended up in that kind of second condition, in the condition where all the empties were removed, they did not hang around and they did not contribute as many classifications. Now, it took a while to kind of think about, what the different causes could be, but there's a conclusion that, we can't just treat people like another algorithm. If you kind of take away the variety and the diversity of the tasks that they're contributing and they're working on, that can sometimes have negative side effects of people getting sick of just having to either classify all zebras all the time, or in the case of the Galaxy Zoo type example, having to classify, sometimes the hardest images or the fuzziest kind of blob galaxies that it's unclear what classification morphology type should be used. And so I kind of use this as an example to kind of just say that, sometimes the choices that we make when it comes to, what workflows we choose and how we choose to combine kind of these computational and human skill sets, it's important to remember that we do need to keep our participants first in mind and really try to be respectful of their effort, and really consider what impacts using some of these computational tools could have on their experience and could have on their ability to contribute to projects.
So I'm thrilled to share about our new partnership between NASA and the Zooniverse, specifically our Zooniverse teams at the Adler Planetarium in Chicago and the University of Minnesota, leveraging the expertise across our organizations. The partnership opens up even more opportunities for the public to experience participating in great NASA science, and for NASA researchers to benefit from interaction with and insights from the Zooniverse public participants and our Zooniverse internal team and the broader citizen science community. An exciting part of this agreement is that NASA is pledging support of the development and maintenance of this cutting-edge citizen science platform. It's a marker of NASA's commitment to citizen science and supporting tools that are being broadly used across the community. The partnership will also spark new innovations in the integration of machine learning and the development of advanced research tools within citizen science. So this summer's citizen science webinar series has touched on so many different elements of best practices and design goals for citizen science. And it's highlighted so many of the wonderful voices and perspectives within our community. A key thread throughout has been showcasing NASA's commitment to citizen science, both for the research impacts and for the public good. This is a screenshot of NASA's citizen science webpage, displaying the over 20 different active projects led by NASA researchers. So here in red, I've highlighted the many NASA-Zooniverse projects in the mix, from Disc Detective to Floating Forest to Snapshot Wisconsin to many more. And over the next 2 years and beyond, I look forward to seeing this page continue to grow, with quality projects following the best practices and principles heralded throughout this summer's series. Part of our new partnership is recognizing and building on pathways for citizen scientists to know about the broader ecosystem of NASA-related citizen science efforts. So for example, in July, we were able to start advertising to Zooniverse participants that they can opt in to receive newsletters about other NASA citizen science projects and efforts outside of our platform. This just shows a screenshot of your Zooniverse notifications page with that particular opt-in section highlighted. So through this new partnership, there are also a number of ways we're engaging with the NASA research community, from providing project builder workshops, both short ones and also very in-depth full-day workshops, to improving the Zooniverse mobile app for all projects, including for NASA projects and their particular sort of functionalities, to new functionalities we'll develop, particularly starting in year 2, which is starting in April of 2021, based on the listening sessions we'll be carrying out throughout this year. And finally, we'll be having a data scientist on board to help teams aggregate their data and use the advanced tools that Cliff described in the previous section. So speaking of Cliff, he's going to take on the last slide and describe this new opportunity to you.
Yes, and an exciting kind of development in kind of NASA citizen science has been funding opportunities through the NASA Roses call. And so there was actually just a call that finished for Earth Science, the Citizen Science for Earth Science program. And that was closed on September 11th, but there's still plenty of time to apply for another funding opportunity, the Citizen Science Seed Funding Program. And so here, this is any NASA division other than Earth Science, which was covered by the previous call, is open to basically apply for seed funding. And so relevant deadlines here, very important. Required NOI deadlines coming up on October 13th, and a proposal deadline December 11th. But as noted in that solicitation, proposers are recommended to kind of reach out to citizen science platforms. So especially if you are interested in building either a Zooniverse project and kind of making use of the platform, we'd love to hear from you. And so if you are interested in basically just using existing resources and existing tools, there's no requirement to reach out, but we would still love to hear from you and would be happy to provide a letter of endorsement. And especially if you are interested in kind of going beyond and either creating custom tools for your own project or creating other new features on the platform, we would love to hear from you. And so with that, we'll kind of finish up and take any questions, and we'll be sure to refer to our contact information. Feel free to email us at contact@Zooniverse, and we look forward to hearing from you and building projects with you in the future.